Okay, so now that we've had an opportunity to understand how the um, the development of a monocyte and how that ends up becoming a macrophage, we're going to now talk about how atherosclerosis begins. In particular, how that LDL, this LDL from how this LDL gets into the intima of the coronary artery, because it's that LDL that really starts to set off this development and progression of atherosclerosis. So that's what we're going to talk about now, is how does that LDL get into the coronary artery intima to help begin this process of atherosclerosis. So there's really three different things we need to talk about. It's first that LDL moves from the blood of the coronary artery and freely enters the intima, which we just saw from that slide. We also have LDL entry causes an increase in MCP1 activation on the endothelial layer of the coronary artery. So we saw that as well. That was step number 6 from that previous slide. Also, the monocytes enter the intima from the blood in the coronary artery due to MCP1 and the endothelial cell adhesion molecule. So this is a little bit more detail as to how MCP1 attracts or gets that monocyte into the intima of the coronary artery before it becomes a macrophage. So we're really going to talk more in detail, essentially about 5, 6, and 7, and 8 here. So this chart, the first part is how LDL readily enters the intima of the coronary artery where they may be modified. So the important thing to know is that this LDL that comes from the food that we eat is able to travel in the blood and then eventually make its way into the coronary artery intima. It's able to move through freely. And once inside, what happens is there's an oxidation of lipids in the ApoB. Now, a few things to understand is that oxidation just means the changing of something. If you ever seen something rust, well, that's oxidation, so it's being broken down. In this particular case, an LDL is being changed or modified into a modified LDL through what's called free radicals. Well, free radicals are just special oxygen molecules that are hyperactive. They're missing an electron. And what happens is when they miss one of those electrons, it becomes very hyperactive and it goes around the body and causes damage. In this particular case, this free radical will cause damage to an LDL, causing it to become modified or changed its shape. Along with an LDL, you also have what's called an ApoB. Think of an ApoB right here, if this is my fist. An ApoB would be something that actually wrap around. If my fist is an LDL molecule, a ApoB would be a protein that would wrap around. Think of a rubber band that'd be wrapping around my fist. In this case, this ApoB is a protein that wraps around the LDL molecule. You need to have an ApoB in order to have a functioning LDL. Well, what happens is those same free radicals will also attack the ApoB and modify it as well. So essentially what happens is the LDL is changed from a normal LDL into what's called a modified LDL due to free radicals. Well, once this LDL becomes modified, this modified LDLs are pro-inflammatory. Pro-inflammatory just means that it causes inflammation or injury in the body. So it'll attract monocytes to the cell and it upregulates other bad proteins in the intima, which can increase plaque formation. So really that modified LDL is one that really starts to set off this atherosclerotic process. There are some other chemical modifications of the LDL that takes place, but the main one you should understand is that the oxidation of by these free radicals or hyperactive oxygen molecules is really what sets or changes the LDL into a modified LDL that really then progresses the atherosclerosis moving forward. So again, this is just a slide that just illustrates or talks about what we just did, written step by step for you to look at. And here, how does an LDL become modified? So with those free radicals to become an oxidized or modified LDL? Well, it's about a 4-step process. And here is what we have is a normal LDL And these little blue droplets are essentially made up of cholesterol and triglycerides or fat. And then these dark blue bands here are that ApoB protein that wraps itself around the rest of the LDL. So this here is an LDL that's a normal LDL containing cholesterol, and again, it's attracted to LDL receptors throughout the body, delivering cholesterol to the tissues. However, in someone who's unhealthy, that might be suffering from obesity, lack of exercise, a poor diet, they're going to have a higher amount of these free radicals or these specialized oxygen molecules. And what happens is these special free radicals or oxygen molecules will come in and they will start to attack these various lipid molecules on the LDL. And it starts to change the shape and conformation of these little droplets, as represented by the change in color. And so at this point, now you start to have the progression of the LDL to becoming modified. But it's not there quite yet. What happens over time is those free radicals will then start to attack the ApoB protein that's wrapped around the LDL. And as illustrated here, what ends up happening is now these ApoB molecules are attached firmly with these droplets, these modified droplets on the LDL. And what happens is once we have this ApoB 100 is now attached firmly with these lipid droplets, now what's happened is you become a modified LDL. And no longer is the LDL attracted to the LDL receptor throughout the body, but instead now the oxidized or modified LDL is only recognized by scavenger receptors on macrophages. So this step number 4 is going to be really important in just a moment as we talk about a macrophage and the development of atherosclerosis. But what you need to understand is that now we have a modified LDL that likes to form plaque in arteries. So you go from generally a normal, if you will, healthy LDL that delivers cholesterol to the tissues to now, because of the high amount of these specialized free radicals in the body that change the conformation or shape of the LDL to become from healthy to now a modified LDL. And again, the LDL goes from being attracted to LDL receptors on tissues to now being attracted only to scavenger receptors that you will find on macrophages. So that's going to be important. So remember that now these modified LDLs are attracted to scavenger receptors on macrophages, and that's what helps form the plaque in arteries. So that's the first thing. So when the LDL comes in, it becomes modified and a modified LDL. Okay. And again, this is just the step-by-step in words of what we just talked about. You can take a moment to look at these as well in your notes. All right, so here we have the second part is once that modified LDL, or the LDL comes in and becomes modified, what happens? Well, that stimulates the expression of MCP1 in the endothelial cells. So this essentially, right here, this step here is essentially the same steps that we talked about previously here in step number 5 when we talked about the formation of MCP1. So a little bit more detail. So what ends up happening is that now we have the modified LDL. It's going to now cause that endothelial layer of the coronary artery intima to make MCP1. Again, the modified LDL doesn't become MCP1, but rather it communicates with the endothelial layer of the coronary artery to say, hey, go ahead and make MCP1. So it does. And when it does, that MCP1 will attract the monocyte into the coronary artery intima, which we saw in the previous pathway. So now we have the monocyte is now into the coronary artery intima. And again, this is just the step-by-step of what we just talked about. Now what happens is how does it actually get those monocytes in? Because what happens to understand is the recruitment of blood monocytes by the endothelial cell adhesion molecule. So what that means is normally what happens when you have monocytes that are circulating, they don't go in a straight line as followed by this arrow like you would be driving down the road. But rather what happens, the monocytes are going to be ping-ponging, bouncing off of the artery walls back and forth, kind of in a chaotic process. So there needs to be some process to help slow these monocytes down in order to allow for it to move into the coronary artery intima. Well, what we have is there's two proteins that are going to be upregulated in a disease state. And the first is called E-selectin, which is again made by the endothelial layer. And its role is to cause rolling of the monocyte. So instead of having that monocyte bounce back and forth, this E-selectin will help cause that monocyte to start rolling along the endothelial layer. And then what ends up happening is this, you have these two other proteins that are produced by the endothelial layer called VCAM1 and ICAM1. And these proteins, again, VCAM1 stands for vascular cell adhesion molecule 1, VCAM1, and also ICAM1 stands for intracellular adhesion molecule 1s. And what these two, they actually interact with what's called integrins on the monocyte surface. So what that basically means is you have these little arms that stick out, and they help attach to the VCAM1 and ICAM1. And the idea is this sticking will then allow for this transmigration. Trans basically means across the endothelial layer into the coronary artery intima. So that is how you start to get those monocytes that are chaotic circulating through to get them to slow down, roll, and then stick, and then make their way into the coronary artery intima. In a moment, we're going to watch a video of this. I think it's important for you to see things in multiple ways. So we're going to now show a video of this. All right, so this is a video of what we just talked about with the rolling and sticking of the monocyte and helping it get in. So let's just show, we'll kind of do a step-by-step here. So we have a leukocyte here, which is just another name for a monocyte. And here's the coronary artery, the blood vessel, the lumen. And here we have the intima of the coronary artery. This bacterial infection, just think of this as the LDL that's going to then cause inflammation of the tissue. So that's going to trigger the rolling and the sticking of the monocyte, and then that's going to then bring it into the cell. Okay, so now this is going to expand inward, and you're going to see a little bit more detail as what we're talking about. Here's the endothelial cells, the inflammatory signal coming from our encased LDLs. Okay, and you have some other proteins that we didn't talk about. It's not important for us to know, but here comes the monocyte that's now rolling because of E-selectin. And now it's going to roll and it's going to roll, and then it's going to stick due to the VCAM1 and ICAM1. And there's those integrins here that we talked about, those arms that stick out from the monocyte. And they're going to see in just a moment, you're going to see how they attach to the ICAM1. And then there's that sticking that we just talked about in the previous slide. So now the monocyte is stuck, it's stopped, and then through transmigration, meaning it goes through the coronary artery intima layer here. Okay, so we'll play this one more time to give you an idea so you'll be able to see it in full motion now. So here we have the motion with the monocyte is making its way through. It's rolling. Notice how it kind of goes back and forth, up and down. Again, you have the bacterial infection, the LDL here. That's going to cause inflammation. It's going to cause the rolling. The E-selectin is going to cause rolling. The VCAM1 and ICAM is going to cause the sticking. So again, here's our endothelial layer. Here's the inflammatory signal coming from the LDLs saying, hey, monocytes, come to the intima of the coronary artery. And now we're going to have the rolling of the monocyte, the rolling due to E-selectin. And now after this, you're going to have The integrin is going to interact with the VCAM1 and ICAM1, and that's going to cause the sticking of the monocyte. And then through transmigration, the monocyte is able to enter the coronary artery intima. All right, so that should give you some idea as to how the coronary artery, how the monocyte is able to make its way into the coronary artery. All right, so that video was a good video that gave an overview of this process of the rolling and then the sticking. Make sure, again, on the exam, you don't need to worry about what these abbreviations stand for. So in other words, I will give you these, what these abbreviations stand for, but you do need to know what they do, okay? Now let's take a moment here, and I want you to pause the video, and I want you to go through the notes and try to answer these 5 questions, and then we'll go over them together. Okay, so using the notes, hopefully you filled these in. Again, it's important to take some time to do this. It helps give you an idea of what you've learned so far. Again, let's go through step by step for each of what these are. So the first, you have the monocytes enter into what part of the artery wall? It's going to be the intima. Once inside the monocytes, they differentiate into a macrophage. Differentiate is just a fancy word for change. Once inside the artery wall, LDL is modified by the oxidation of lipids in ApoB. So basically those free radicals or those special oxygen molecules will change the shape of the LDL to become modified. These modified LDLs will activate MCP1 that is responsible for attracting monocytes into the artery wall. And then the adhesion molecules E-selectin is responsible for rolling the monocyte, while VCAM1 and ICAM1 are responsible for the sticking, which then leads to the monocyte to do what? To help bring it into the coronary artery intima. All right, so what this section talked about was how the development of how LDL makes its way into the coronary artery intima, and then it starts to trigger the process, the beginning stages of atherosclerosis. So again, take a moment, look over these notes, and then we're going to move on to the next phase, which is the development of atherosclerosis once that LDL, that monocyte, is into the cell.